Hello good people, I'm going to continue talking about ionic compounds. So far I have mentioned that metals, highlighted here in red, will donate electrons and become cations, positively charged particles. On the other hand, nonmetals, shown here in blue, will gain electrons and will become anions, negatively charged particles. And I have also stated that an electrostatic force or an electrostatic interaction between the positively charged cation and a positively charged anion will result in an ionic bond and finally give us an ionic compound. I'm going to explore this concept a bit further and demonstrate how we can use chemical symbols to indicate what is going on. I'm going to use common table salt or sodium chloride as an example. Sodium chloride is made up of a sodium atom and a chlorine atom. But how do they actually come together? Let's take a step back. What do we know about sodium? Sodium is a metal that will lose or donate an electron to give a sodium cation. So I will go from sodium to sodium cation. However, I have also said that for this to happen, the sodium atom on the left needs to lose an electron. Okay, so on the right I will have the sodium cation, but I will also have an electron. Note that the overall charges are balanced. On the left I have a neutral sodium atom, and on the right I have a positive sodium cation and an electron. Overall, the right-hand side is also neutral. It has one positive particle and one negative particle. What do I know about the chlorine? Chlorine is a nonmetal, and it will gain or accept electrons. This means that I will end up with a chlorine anion. I have said that for this to happen, the chlorine on the left needs to gain or accept an electron. So on the left, I also need to add an electron. Note again that overall the charges are balanced. On the left-hand side, I have one negative particle, and on the right-hand side, I have one negative particle. Initially, when I introduced the concept of cations and anions, I said that you do not need to worry where this electron goes or where this electron comes from. But now, we can actually connect the story. I could say that this electron that is lost by the sodium is exactly the same electron that is also gained by the chlorine. The sodium will donate its electron to the chlorine, and in the process, the sodium becomes a positively charged cation and the chlorine becomes a negatively charged anion. I can now take the sodium cation from the first equation and the chlorine anion from the second equation, and that will give me the sodium chloride, an ionic compound that is made up of a metal and a nonmetal. So we have sodium chloride. Note that it is not sodium chlorine, but sodium chloride. I will examine the naming rules for ionic compounds later on. For now, I want to examine another way that I can combine these two equations at the top. So let me just copy them down. Here we go, and approach this from a mathematical or account-keeping method. So I have two equations, equation 1 and equation 2. I can combine them, I can add them. However, I can only add them if the number of electrons in both equations is the same. In this case, that is true, so now I'm going to add these two equations. How do I go about it? It is a matter of combining everything on the left and then combining everything on the right in both of the equations. So let me start. From the first equation on the left, I have the sodium atom. Then from the second equation, I have an electron and I have a chlorine atom. So that is the left-hand side. Then I move over to the right-hand side. On the right-hand side, from the first equation, I have the sodium cation and an electron. And from the second equation, I have a chlorine anion. And now, everything that is exactly the same on both sides of this arrow can be cancelled. So I have one electron on the left and one electron on the right. I can cancel them. Please note, I cannot cancel sodium and sodium cation. They are not exactly the same. This one is neutral, while the sodium cation has a positive charge. Once I have cancelled everything that is exactly the same, I can rewrite the equation. On the left, I will have sodium plus chlorine, and that will give me a sodium cation and a chlorine anion. And these two ions will combine to give the ionic compound sodium chloride. Please note that what I have written here at the bottom does not necessarily represent how this reaction actually happens. This is just a way of symbolically keeping track of what is going on with our particles. I'm going to now look at another example. I'm going to replace the sodium with a magnesium. So let me get rid of this and write down magnesium and chlorine. Magnesium is a metal, and therefore it will give me a magnesium cation. Based on its position in the periodic table, this cation will have a charge of 2+. This also means that the magnesium on the left will have lost or donated 2 electrons. So here they are. Chlorine, just like before, will give me a chlorine anion. And in order for that to happen, I need to have 1 electron. Or more precisely, the chlorine atom needs to gain 1 electron. Now I need to be a little bit careful. The magnesium has liberated or donated 2 electrons. The chlorine accepts only 1. In other words, there is a spare electron floating free. And remember that in the previous example I stated that the electrons donated by the cation are the same electrons that are accepted by the anion. If the cation is donating 2 electrons, then the anion needs to accept 2 electrons. I cannot simply write a 2 here in front of this electron. The entire second equation needs to be multiplied by 2. So now I will have 2 electrons that will be donated to 2 chlorines to give me 2 chlorine anions. It is only now that I can take the magnesium cation from the first equation and combine it with 2 chlorine anions from the second equation to give me magnesium chloride. However, this is not completely correct. The left-hand side has to equal the right-hand side. On the left, I have 1 magnesium and 2 chlorines. On the right, I have 1 magnesium and only 1 chlorine. I need to indicate that I actually have 2 of them. Where does that 2 go? It does not go in between the magnesium and the chlorine symbols. It goes as a subscript after the chlorine symbol. So now I can correctly state that 1 magnesium cation and 2 chlorine anions will give me 1 magnesium chloride, which happens to be made up of a magnesium atom and 2 chlorine atoms. Note that the charges are balanced as well. On the left, I have 2 positive charges and 2 negative charges, which means overall it is neutral. On the right, I have an ionic compound, which is also overall neutral. How does this look from an account-keeping point of view? Well, let me copy the equations again. Here they are, and now I'm going to combine everything that is on the left-hand side and then everything that is on the right-hand side. On the left, I have a magnesium atom, then 2 electrons and 2 chlorines from the second equation. And on the right, I have a magnesium cation and 2 electrons from the first equation and 2 chlorine anions from the second equation. Everything that is exactly the same on both sides can be cancelled. In this case, that means these 2 electrons. And I can now rewrite this a little bit. I have a magnesium atom and 2 chlorine atoms. That will give me a magnesium cation and 2 chlorine anions. And once again, these 2 will combine to give me my ionic compound, magnesium chloride. Now I admit that this process is a little bit involved. Luckily, there is a shortcut that helps us determine how cations and anions will combine and what sort of ionic compounds we can expect. So why did I not just show you the shortcut and skip this entire lesson? I wanted you to get an early appreciation for balancing of equations and keeping track of electrons. The left-hand side has to equal the right-hand side in terms of content and charge. I will explore the shortcut and the naming rules for ionic compounds in future videos. That is all for now, and I will see you on the flip side.